Oh, thank you, Stuart. Okay, well, hopefully everybody can see the screen there, and so hopefully that's clear. So hello and welcome to this module on the new Climate Environmental Assessment Standard. So my name's Colin Holm. I'll be delivering this presentation today. I'm the Senior Advisor in Sustainable Development and Climate Change at Highways England. Okay, so in terms of content today, we'll start with a general introduction to the new DMRB Environmental Assessment and Design Standards, and then we'll go into some of the key features of this new climate standard. Okay, so by way of an introduction, I'm going to talk about a few key things today. So I'm going to talk about the benefits of the new approach to environmental assessment. I'll talk through some of the requirements in terms of climate and environmental assessment for projects in particular. I'll show how consideration of climate relates to project delivery. And I'll say some words about how assessment is to be undertaken. I think at this point it's important to note that because this is a new standard with requirements and advice, we won't be going through everything today, but hopefully this will serve by way of an introduction. So who's this module aimed at? Hopefully you may recognize your role on that list. So it's primarily aimed at those such as project managers, wider project team, design consultants, contractors. But of course, if you're not on that list, you're more than welcome at this session. Okay. Just a word at the start about the new design manual for roads and bridges. And basically this slide is, well, it's giving you a bit of an indication about what GG 101 tells us in relation to language in the DMRB. So you'll notice that in all environmental assessment standards, there's a style to the way that clauses are structured. However, the verbs used have a defined meaning to help you understand essential or permissible approaches. So we've got a list of verbs there. We've got must, shall, should, may, can. They've all got a very specific meaning in the design manual for roads and bridges. A couple to note are must, which is a statutory or legislative requirement, so something that's required by legislation and very much relevant to this standard that I'm going to talk about today. There's also shall, so they're requirements, they're must-dos that Highways England or the overseeing organisation is requiring you to do. And there are further standards, which are perhaps slightly less strong. The should, advice expressed as a recommendation, may, a permissible approach, and can, used to introduce notes. It may clarify a concept. So that's just a note on the language. Okay, a note on implementation here as well. It's important to note that these standards are live now. So if you Google DMRB and get into our standards for highways, you'll immediately see this LA 114 standard there if you want a bit of probing. So these standards are to be implemented as soon as they are published. There are some limited exceptions to that. So where the contract has reached a certain stage, that would result in significant additional expense or delay. So that's a potential exception. But there are options available to project teams, and they are either just to implement standards or consider undertaking a sensitivity test to confirm if the new approach to assessment would change the conclusions or significantly the conclusions or sufficiently of the assessment. So the important thing here really is to note that it's live now. These are live standards. Those must, shalls, shoulds, and mays are all in effect now. They're published, and they should be integrated into your environmental assessments. Okay, so there's a slide here about the structure of the design manual for roads and bridges. Well, of the environmental assessment chapter in the in the design manual for roads and bridges. So in terms of how that section of DMRB is organized, it's really divided up into principles, assessment techniques, and design. So you'll notice a whole suite of documents. There are those at a higher level which give those principles in relation to environmental assessment. Then it gets into the nitty-gritty of assessment techniques, and there are some specific documents that relate to design. Where this standard fits is highlighted here. So we're talking about an assessment technique today, LA114 climate. Okay, so this slide is really an indication of the structure of the LA114 document. So you can see, actually, it's a pretty standard structure. So if you go into any of those environmental assessment techniques standards, you'll see pretty much similar. There's a forward, introduction, abbreviations, terms and definitions. I'll speak a little bit more about that later. Scope, principles and purpose, assessment methodology, some more of that to come as well, and monitoring are all covered in the document. Okay, so the presentation is broadly going to follow that structure. So in terms of scope, so what's covered in this standard? What we're doing is essentially this document is conforming to the EIA directive, so that's something that is relevant to the document, and it is covering a couple of specific aspects in that EIA directive. Article 3 of the directive lists factors that for direct and indirect significant effects should be considered for. So the key word there is these factors, and one of those factors is climate. So if you look at Article 3, you'll see a range of different factors listed. You will see climate. And there's a bit of wording there as well that it covers the impact of the project on climate and the vulnerability of the project to climate change. So in the technical language of the of this standard and of the EIA directive, there are two elements to climate. One is the impact of the project on climate, in other words, the greenhouse gas emissions, and the vulnerability of the project to climate change. adaptation. So climate isn't just about carbon, if you're focused on that. It's also about adaptation to climate change. Okay, so we've got just to kick this off really, we've got a section on terms and definitions. Now, if you're familiar with climate change, the field of climate change, you'll know that it's riddled with lots and lots of technical terms. If you look at the terms and definitions in this LA114 standard, you'll see quite a lot of technical terms and a concise definition applied to each. So hopefully that should make the standard a little bit more explanatory. We've tried to be clear on what we mean. I've picked out 3 definitions here. I can't go through them all, otherwise we'd be here for a very long time. But I've picked out climate, carbon emissions, CO2e, and resilience. And I just think it's worth reflecting on these for a moment, just so that we're all on the same page, if you like. So by climate, I think we all know what climate means now, because it's covered so much in the media. But just to be clear, we're talking about long-term weather conditions prevailing over a region. We're not talking about short-term weather. We're not talking about the whether it's going to rain in Leeds today or whether it's going to be sunny in Bristol today. We're talking about long-term trends prevailing over a region, long-term patterns and trends. So carbon emissions, CO2e. This is interesting, because I frequently talk about climate change, and actually there's still a little bit of confusion about what we mean by carbon emissions and CO2e, and sometimes people mistake CO2e or CO2 equivalents for just CO2, carbon dioxide. That's not what we mean. So what we're talking about, we will probably use in this presentation, we might talk about carbon emissions, CO2e, or greenhouse gas emissions as well. Really, these are shorthand terms for the emissions of any of the 7 greenhouse gases that contribute to climate change, or at least the 7 that are listed in the Kyoto Protocol. There are actually more greenhouse gases than that, but there are 7 that are listed in the Kyoto Protocol, and that is what we're accounting for in this standard. It's useful shorthand to express them as a carbon dioxide equivalent. Just to kind of just to put a little bit more meat on the bones there. There are other greenhouse gases that are in that Kyoto list, things like methane, things like nitrous oxide. They have different lifespans in the atmosphere, and they have a different global warming potential to carbon. So it can get to be quite a complex picture if you're talking about methane, perhaps, which has 56 times the global warming potential of CO2, or nitrous oxide, which has 280 times. And you know, those same greenhouse gases have different lifetimes, as I say. So nitrous oxide has a long lifetime in the atmosphere, methane has a short lifetime. All becomes quite complex unless you abbreviate it to some sort of normalized equivalent. So what we're talking about here when we talk about greenhouse gas emissions, carbon emissions, CO2e, we're normalizing them to one single measure, CO2e, carbon emissions. Resilience, we'll talk quite a bit about this today as well. So the definition here is the capacity of a project, or lack thereof, to withstand the adverse effects of climate change. So this is, again, we'll use a number of related terms like resilience, adaptation to climate change, etc. Another key focus of this standard. Okay, so as you're reading LA 114, you'll come across the principles and purpose. Actually, it's worth being clear on this, really, in that well, obviously, one of the purposes is to implement the EIA directive in relation to its requirements for climate change, but also to align with government expectations and the planning system in England. One of the key purposes of this document is to align with the Climate Change Act 2008. Historically, if you were looking at the Climate Change Act before this year, you would have seen that it required an 80% reduction in greenhouse gases by 2050. But this year, that was actually updated to 100% reduction in greenhouse gases by 2050. So that is a legal requirement in the Climate Change Act 2008. So that's why this document is here and what it's aiming to help achieve and contribute to. So it's important to be clear about that, that we're working towards net zero in terms of the Climate Change Act. Another principle that kind of is reflected very much so in this standard is that by considering greenhouse gas emissions early in the life cycle of a project, that offers the greatest potential for the reduction of greenhouse gases. This is something that you'll pick up in lots of the literature about responding to reducing greenhouse gases. So, for instance, you've got notable documents like the Infrastructure Carbon Review and things like that, which all look towards that early part of the life cycle, which has the greatest potential for reducing greenhouse gas emissions. If you can imagine, if you consider them late in the design, or if you consider them retrospectively, you've kind of almost got locked in greenhouse gases there. So really important to consider them early. And actually, this just a wider note on this. It's something that we also reflect on in our other standard, GG 103, where we talk about focusing early in the life cycle to reduce things like greenhouse gas emissions. We've got a slide here about the structure of the assessment methodology that's contained within the standard. Just to emphasize here that it's a little, although the actual headings in the standard, such as scoping, study area, baseline scenario, data collection, significance, design and mitigation, are common to environmental assessment standards. This one is a little bit different because of that split between reducing greenhouse gases and addressing the vulnerability of projects to climate change. The standard uses those same headings, but you'll notice it applies them twice, once in relation to impacts on climate and once in relation to vulnerability. Okay, it's in terms of the assessment methodology, I've tried in this table really to sort of illustrate a few of the key differences between assessing impacts on climate and assessing vulnerability to climate change. There's advice in there about scoping. So there's you'll see that there are thresholds for further assessment in relation to construction and operation carbon greenhouse gases, in relation to scoping. In terms of vulnerability, the scoping is much more about identifying if changing climate is likely to adversely affect construction and operation. So you see a kind of a different approach there on each side. In terms of baseline scenario for impacts on climate, reducing carbon, we look at current and future greenhouse gas emissions under a do minimum scenario. In terms of vulnerability, it's more about the historic and current weather, climate data and events. Some very useful sources out there that the standard will direct you to. In particular, it looks at the identification of climate trends in the UK climate projections. So if you're familiar with those UK climate projections, they're produced by the Met Office, and the latest climate projections are the UK Climate Projections 2018, UKCP 2018. Okay. There's also differences in terms of data collection. So in terms of impact on climate, you're looking at the identification of potential sources of greenhouse gas emissions in construction and operation. In terms of vulnerability, it's about identification of project receptors and their vulnerability to climate change. So what are the features in that project which might be impacted by a change in climate? And in terms of significance, the assessment varies as well. So, so the test of significance for impacts on climate is against carbon budgets, and the test for vulnerability is based on a risk assessment, identifying hazards and benefits, likelihood and consequences. So a little bit more about that in a moment. But I think at this stage it's really important to emphasize that those carbon budgets are published up to the 5th carbon budget. So in terms of when you're assessing impacts on climate, you're assessing against the government carbon budgets, what you'll note is that those that are in the public domain are to the year 2032, which is the 5th carbon budget date, and they are currently aligned to the previous Climate Change Act targets. So you'll notice they were published prior to the update to the Climate Change Act and its requirement for net zero. What we know is that the Committee on Climate Change will publish advice on the next carbon budget, and they say they'll do it in next September, at which point net zero in the Climate Change Act will be taken into account. So the budgets may be subject to change, which may be an issue to be cognizant of in upcoming projects. Okay. So in terms of the assessment methodology and how it relates to design and mitigation, this is a really important element because what the EIA that you're undertaking should seek to do is to minimize greenhouse gas emissions in all cases. That's really important because we have got that net zero target and we need to react to that. So we need to look at all opportunities to reduce carbon within the design of a scheme. So the standard presents a hierarchy, a sort of a framework by which you can go through your the potential ways in which you could reduce greenhouse gas emissions. So so in all cases, you follow this hierarchy. If you can't avoid, reduce. If you can't reduce those carbon emissions, then there are instructions around remediating those carbon emissions. Wherever possible, aim towards the high end of that hierarchy, and then work your way down. For vulnerability to climate, a similar hierarchical approach is applied. Really, we're asking how the project can be adapted. How can it be made more resilient to climate change? And where significant effects are identified, a hierarchy is presented in LA 104, which you should work for and reassess once you've gone through that hierarchy to reduce significance. Okay, so so a word or two about reporting, which kind of gives you a little bit more meat on the bones about how you might look at significance, really. So this table is presented in the standard, which really shows you how you might calculate your carbon and consider them against the government's carbon budgets. So basically what this is asking you to do is to calculate the carbon impact of the scheme for construction and operation, and then to assess what the difference is of this and a do minimum scenario. So it's a difference between doing something and doing minimum. And then the comparison is to the relevant carbon budget. So we're considering this for operation and construction, where looking at the difference between do something and a do minimum scenario, and asking, would that have a material impact on the government's carbon budgets? So there's a table to work through within this standard. Okay, on the risk side, on the vulnerability side to the project, in terms of assessing climate change impacts, we have a slightly different approach to assessing significance. So what we're asking projects to do is to look at likelihood, so the likelihood of an event occurring during the project lifetime, and to rate that on a sliding scale, if you like, from very low to very high. So there's definition around the probability and frequency of occurrences, which allow you to line up to very low, medium, high, or very high in terms of the number of times a particular event, for instance, a flooding event, might occur on the project. There's then a measure of consequence, which we ask you to take into account. Again, that scale running from negligible right through to very large adverse. So what is the disruption that might occur as a result of that event? Is it going to be very small scale, or is it going to be large scale, long lasting? So again, you've got those work through elements where you can align the impact to either to both the likelihood and the measure of consequence. And the standard actually goes beyond that, and once you've gathered that data, there is actually a significance matrix which allows you to, which will show you when you've done this assessment as to whether effects are significant or non-significant. So a word about monitoring. So monitoring is particularly important in relation to climate change. But actually it's quite well integrated into existing systems of monitoring if you look at the requirements in the standard. So for impacts of projects on climate, so the impacts on those GHG emissions, the standard requires quarterly greenhouse gas emission returns during construction and operation phases in accordance with the overseeing organisation's requirements. So in Highways England, we have a carbon calculation tool, so that will serve as the monitoring process that underpins construction and operation in relation to greenhouse gas emissions. For vulnerability to projects to climate change, really it's more about monitoring the condition of assets. So once a project's operational, asset data shall be managed, maintained and monitored to ensure the project design is operating as intended. So is your bridge, your tunnel, your road continuing to operate as intended? And there are asset monitoring management processes in place to enable that judgment to be made. Okay, so a few just examples. It's as with all standards, these are technical requirements, are things that either you must or shall do, or you should do. So there are things that you need to comply with. But the outcomes of that can look quite different depending on the actual project that is being delivered. And I put a few images in here just to sort of reflect that actually the environmental assessment project can make a real difference to the way that projects look and the way in which they are effectively either resilient to climate change or low carbon. So a couple of examples here, if I work kind of clockwise through them. We've got an example of a raised carriageway with wider culverts there on the A66, which is in response to an increase of flooding in that area. So that's one of many possibilities for dealing with flood risk. Actually, well, I'll work downwards. I'll work anti-clockwise. Actually, if the image below is about connecting vulnerable habitats on the A590. So you've got you had a project there, a road scheme, and one impact of climate change that was picked up was that this, being in a nature improvement area, had a range of habitats that might be vulnerable to climate change. And one thing that, if you look at documents like the UK Climate Change Risk Assessment and other documents that have been published around climate change and its effects on the UK, are that habitats and species are at risk from climate change, particularly those habitats and species that are isolated or fragmented. So one of the best things you can do in terms of increasing the resilience is to join those habitats and species up so that they can move. So if you can imagine, you might have an event, a flood event or something like that might occur. It might deleteriously affect a fragmented habitat. If you've got a joined up habitat, there's more space for species to move and to withstand those events over a larger scale. But there really isn't. It's certainly one of the best opportunities to do that is by decreasing fragmentation, connecting habitats together, and a linear feature like a road network often provides an ideal opportunity to do that. And finally, there's a slide here. Often it's quite difficult in some of the pictures to convey what low carbon might mean on a project. But here's an example where on the A160 upgrade, where they've really picked up on some circular economy principles. So they've tried to efficiently use materials and resources in the design of that particular road upgrade. So there are things in that scheme like the use of warm asphalt, sort of a lower temperature asphalt, which has reduced carbon emissions, and the incorporation of existing materials in the road into the new pavement. All of these things reduce the embodied carbon that is within the materials, and they also reduce the things like time spent on site and transport of materials. So they're often a win-win. So a brief summary of what we've talked about today. So the DMRB now provides a standards framework with clear requirements, and there's, as I've mentioned, there's that consistent terminology of must, shall, should, can, may. So hopefully what you'll see when you read LA114 are clear requirements, so you should get the direction that you need when you look at it. The topic is made up of two elements. That's a key factor here. It's not, as historically has been the case in environmental assessment, where you might just see an assessment of the impact on climate change in terms of the carbon, GHG emissions. It's also about the vulnerability of the project to climate change. So it's about looking at those climate projections and asking the question, will the function of this project still be viable within a changed climate? Carbon emissions and resilience to climate change are given equal attention here, so we're not saying one's more important than the other. Key differences are in the approach to the assessment of each element. So I highlighted that table a little bit earlier. You can see it's the same broad approach in terms of structure, but the actual, in terms of detail to that approach, it's quite different. And as emphasised, there's a hierarchical approach to design and mitigation. So a few links that you may find helpful. Actually, as with the terminology, I could have listed lots and lots of links here, but I've just focused on three. If you want an idea of how Highways England has assessed its vulnerability to climate change. We, under the Adaptation Reporting Power of the Climate Change Act, we publish periodic climate change risk assessments, and you can see the latest one on that link. I've talked in terms of monitoring about the use of the Highways England carbon emissions calculation tool. There's a link to that there as well, and if you go onto that website, you will also see guidance and training of how to use that calculation tool. And for a big picture view on what climate change means to the UK, it will help inform you of just exactly what things like increased rainfall intensity and warmer, drier weather might mean. You've got the Committee on Climate Change evidence report on the UK climate change risk assessment for infrastructure there as a link, so that might guide some of your thinking here. Okay, thank you.
That's great, thank you, Colin. We've had some IMs as we've been going through. A number of those have been addressed, and what we will do is we will keep a record of those and come back to you. So we'll provide a definitive answer against each of those points that's been raised, and respond to all the attendees of this session. So thank you for your attendance today. Colin did highlight at the end, if you want to provide feedback, there are two principal routes to doing that. There's the usual standards for highways, which is really about improving the quality of the standards that we have, email address, which you'll find in DMRB, and the second element is around providing feedback directly to us, which we would ask you to put back through the environment mailbox, which I gave the address in the IM. And specifically, if you could identify that it's climate training in the subject box, that will help us to coordinate the responses that we give to you. So thank you all for attending today, and we'll close the session now if we can. All right, Colin?
Okay, thank you. Thank you,
Thanks,
everyone.
everybody. Cheers, then.